How about it? Let's take a look at the problem of the day. It says a rectangle has dimensions of x and x plus 2. A triangle has lengths of x plus 4, and x plus 6. Both perimeters here are equal. Then it says find the perimeter. Notice I left that as a singular perimeter because they're both the same, right? Both numbers are the same. That's what we're going to prove. We're going to show that this works if we think this through. Basically, let's take a look at this problem, see what's happening. First of all, dealing is we are being told that the perimeters are equal. So what we got to do is take both of these figures, first the rectangle, establish what is its perimeter, and also the triangle. Now there's one hitch to that. We have this little crazy x that is keeping us, we don't know what it is going to be. We could put all sorts of numbers in for x as long as these don't go negative. Certainly can't have any negatives or a 0. And we can get all sorts of kind of numbers, but we don't want to have any numbers on like x plus 2 can't get us to a 0 or a negative. And certainly there, that takes us out. We've got to have positive values, and so I'll take care of it from there. But where are we going to go with this? Let's talk about perimeter. First of all, perimeter of the rectangle. You got to be careful with this, all right? This is a big P for perimeter and RECT for rectangle. What is happening here is we have 2 lengths plus 2 widths. Now notice they gave you dimensions. But what we need to do is we put in the, let's say, well, it doesn't really say which is which, right? So I'm going to let x plus 2 go as the length, x go as the width, because we tend to like that, don't we? So let's see what happens here. We put in 2 times x. I just said differently, didn't I? It's okay, as long as we put them in there in the different places, and we're going to distribute that 2 through our x plus 2. Now, keep in mind, I'm not giving this a certain number. I don't know what that number is yet, but I do know on the other side of my page here, it's equal to the perimeter of the triangle. And the perimeter of that triangle is equal to x plus 4. Keep going underneath my picture, good. And adding that into x plus 6. And no distribution needed here, no distributed property coming to visit us. It's just basically put the like terms together and see what we got. I'm getting an x and an x and an x. Put a 1 in front of all those. 1 plus 1 plus 1 more. You get 3x. I'm getting a 4 and a 6. Gives me 10. So there's the perimeter of the triangle. Again, we don't know what x is, but that's what we're going to find out. Let's go ahead and simplify. This looks a little messy. Let's go ahead and simplify this out. It's going to be 2x. That was easy. Actually, it all is easy. All you got to do is multiply by 2. Let's add another 2x. But let's remember we're going to do what here? We're going to, yeah, you got it, distribute the 2 by 2. That's going to give us a 4. Be careful. Make sure you get all your multiplications in. Those 2 go together, and finally we have something that we can work with. There's the perimeter of the rectangle. Here is the perimeter of our triangle. The deal is these 2 pieces, notice I'm circling them for you guys, just for you guys. That tells me they're equal, so we are about to get somewhere. So you're going, thank goodness, we need to get this problem moving. I agree. So let's go ahead and put in 4x plus 4 and set that equal to our 3x plus 10. And things become fairly nice at this point. You're going like, thank goodness, right? I am too. So let's do it. Let's subtract 3x from both sides because we need to get those x's together. Now remember, we can't add 4 plus 3 and get 7. No, if you try that, you're going to have a problem. You're going to get the wrong answer to the situation, and it's not going to work. But on top of that, anytime, remember, if we move things over to the other side of the equals, we've got to do the opposite operation. So we're, in this case, subtracting 3x, and if we do it to the right, we've got to do it also to our left-hand side. So that's what's going on here. Now things look better. I think they do. X plus 4 on the left, equaling to 10 on the right, because say goodbye to those 3 x's. All of a sudden this looks really easy. We're looking for a number plus 4 to give us 10. And for those of you who haven't figured out, oh, this is pretty much easy mental, let me show you one more time. We're going to subtract again from both sides. I call it that addition. Nope, not this time. It's the subtraction property of equality. Now if we added a negative 4 to both sides, which is what we're doing also, you could call it addition property of equality. But anyway, I digress. Let's get the x out of here. We got x equaling 6, and you know what? That's not the answer, is it? The answer is to find what? Find the perimeter. You say, oh, Ernie, I thought we were done. Well, we are pretty much. I mean, it's just all except for shouting and saying, yes, we can do this. Let's put in our 6 into 4 times 6 plus 4. And I'm getting 24 plus 4, which is going to give us 28. I'm betting that's the perimeter, unless we messed up over here. Let's take a look at this part. How about it? 3 times 6, add 10. That's 18 plus 10. Hey, folks, that's another way we come up with 28. Answer to this gig, the perimeters are equal, and they're both, in this case, 28 whatever units we've got. We didn't really say these were inches, feet, or what have you, but whatever units they are in still linear units. And there's your final rule for the day. All right, how about that?